we're still working on conservation of biodiversity, but before we do, we're going to kind of dig into what is biodiversity, how can we measure it, and also looking at some things called biogeographic factors that can affect biodiversity in general. So we're going to be looking at these last 4 questions here. We're going to be doing a little bit of math because you got to be able to calculate the Simpsons Biodiversity Index. All right, but don't worry, it's not hard. Okay, so let's go into our PowerPoint here. All right, so here is the general definition for biodiversity. It's the amount of biological or living diversity per unit area, okay? And that includes the concepts of species diversity, habitat diversity, and genetic diversity. So when we're looking at biodiversity, we're actually not just looking at how many different species there are, which tends to be how we use it a little bit more loosely. But it's also, is there a lot of genetic diversity? Because that's important for resiliency in a population. Because if you only have a few different genes, like everybody's the same genetically in a population, and there's some sort of environmental change, then there's probably not a lot of chance that you're going to be able to survive it. So let's say a disease comes in, and if one organism in the population is susceptible to it and everybody's essentially a clone of each other, then everybody's going to be affected by the disease. But if you have a lot of genetic diversity, then there's probably going to be some individuals that aren't affected by that disease that would survive and reproduce. So a lot of genetic diversity gives a population or a species some resilience to extinction. And then, of course, species diversity gives ecosystems lots of resiliency because you can have a really well-developed food chain if there's a lot of species diversities. So if one species gets lost, then everybody, the other organisms have something else to feed off of. And then habitat diversity, that one, the more habitat diversity you have, meaning different niches available, then that can actually result in a lot of species diversity. And I'm going to revisit this idea of habitat diversity when we look at biogeography. All right, so when we're looking at species diversity, we're going to focus on 2 measurements. One is richness and one is evenness. And then we're going to give like an overall score in a Simpsons Biodiversity Index. So species diversity is, as I said, it's comprised of richness. So richness is the number of different species in an area. So if you count 10 different species in an area, the richness is 10. It doesn't matter if there's 100 of one species, 37 of another species, just how many different species are there, that is the richness. The abundance would be, if each of those organisms would be those population numbers for each of those species, or the total abundance would be all of the organisms if you counted them all up one by one. And we use both richness and abundance when we're calculating an overall biodiversity score. Evenness is how evenly distributed those species populations are. So if you have, say, 4 different species in an area, and maybe one of those species there's tons and tons and tons of, thousands of this type of species, but then there's only maybe 10 or 20 individuals in this population and 10 or 20 individuals in this population. It's not very even because one of the populations is so much bigger than all the others. Whereas if the numbers are a little bit more close together, that makes a community more even. I'm going to show you examples. The more richness you have, the more abundance you have, and the more evenness you have, the more biodiverse it's going to be. And we actually have a math equation called the Simpsons Biodiversity Index that can give us a number. Now, this number, this Simpsons Biodiversity number, the one that we're going to calculate, there's a bunch of different calculations for this. The one we're going to look at is called the Simpsons Reciprocal Index. And for IB, I think they're just going to call it the Simpsons Biodiversity Index. They're not going to necessarily call it the Reciprocal Index. In this case, the higher the score, the higher the number you calculate, the more biodiverse the area is. Now, a number on its own in this, there's actually not even any units. The number on its own doesn't actually mean a whole lot. You really can only use Simpsons Biodiversity Index when you're comparing 2 communities. So if one has a higher number than another, then this one is generally more biodiverse. It's going to be more biodiverse because it either has greater richness, greater abundance, or greater evenness. Okay, so remember, more richness, more abundance, and more evenness means higher biodiversity. You could have two ecosystems that have similar richness, but the evenness is different, and then the one that's more even would be more biodiverse. And the abundance, again, that will play a factor too. What are the population sizes? That's going to play into the equation. So here's how you calculate it. This is the equation. Diversity equals the total number of organisms, so you count all of them individually, times total number of organisms minus 1, divided by the sum of each of the individual populations, okay? So I'm going to show you an example. So here we've got two areas, area A and area B. So if we were to look at the richness for area A, there are 1, 2, 3, 4 different species. If right now we're just going to concentrate on the trees. So the richness would be 4. And guess what? Area B also has 1, 2, 3, 4 species. So the richness is 4. The abundance for the total abundance, like if we were looking at that total population, is 20 for area A. And guess what? It's also 20 for area B. Can you add up all the individuals? All the individual abundances, these populations, however, are different. Like the population of this guy in area A is 4, but for this species in area B is only 1. So in looking at the evenness, area A tends to be a little bit more even than area B, because area B has 9 of the eucalyptus and only 1 of this one. So it's like 9 and 8 and then a little bit, where these guys are a little bit all closer to more of a median number for their populations. So area A and B have the same richness, the same abundance, however, their evenness is slightly different, where area A has a greater evenness than area B. So I'm going to do the calculations for area A and give you an example for that. Okay, so here's the equation. Diversity equals the total abundance times basically the total abundance minus 1. So 20, I told you, 20 times 19. And then underneath is all of the sum of each of the individual populations. So 4 times 3, because that's 4 times 4 minus 1, plus 5 times 4, plus 7 times 6, plus 4 times 3. So the numbers that I put in here, total here is 20, right? And each of the individual populations will be added up down below. So 4, 5, 7, 4. So 4, 5, 7, 4. But each of these we're going to multiply by one number less. So 20 times 19 divided by the sum of all of these together. So 4 times 3 is 12, plus 5 times 4 is 20, plus 7 times 6 is 42, and so on and so forth. So when I get these, that's 380 divided by 86. And that's going to equal 4.41. So would you guess that area A or area B would have the higher biodiversity? Well, remember, the evenness is better here. So if you were to do a little bit of math, you're going to find out that area B should have a lower number. I think you should take the time to give it a shot. All right. And the last thing that I'm going to talk to you about is biogeographic factors that can affect species diversity. And what that means is that you find more biodiversity if, this is kind of called island biogeography. If you've got a mainland here and we were looking at a bunch of different little islands, we would find more biodiversity on a larger island than we would on a smaller island, because that's going to have more productivity. It's just got more, it's probably going to have space for more organisms. And also, if these guys were accidentally migrating from the mainland, maybe they got blown off course, the chances of them hitting a larger island is higher than them hitting a smaller island. So we tend to have greater, the area of an island is greater, means the greater number of species, the greater biodiversity. The distance it is from the mainland as well can affect, so obviously the closer it is, the the higher the biodiversity. The further it is, the chances of it being colonized by a bunch of different species from the mainland is lower. So you can see distance from mainland also. Now, the reason why we use this is because when we're looking at species conservation, if you are putting together or looking at a series of habitats, like national parks and different things, the bigger the national park or wildlife preserve that you have, generally is the higher biodiversity, okay? So the bigger it is, the more biodiversity. And also, so the smaller it's gonna be, the less biodiversity it can hold. And also you wanna have your parks as close together as possible because that allows them to be reseeded by each population. We're going to come back and look at the criteria for conservation areas when we look at in situ and ex situ conservation. So we're going to come back and look at this again. But one thing I did want to mention, though, is when you have habitat boundaries, so when you have one ecosystem right up against another one, you can actually see a pretty high biodiversity number there because there's a lot of habitat diversity. If you have, let's say, a stream right next to a forest, so you have the stream ecosystem as well as the forest. So sometimes when you see these things called edges, they can have pretty high biodiversity around the edges, but obviously that's just because the habitat diversity in that very minute area might be a little bit higher. Okay, well, we will attack the criteria for really effective conservation areas in a different video.